Hi students, today we are going to learn concept of potential. Concept of potential. Before that, we should know what is potential. So, what is potential? Potential is the strength. Strength, or we can say ability of charge due to its position. Okay, so now if you compare or formulate it, we can write the electric potential that is equals to electric potential energy divided by charge. It is also written as work done divided by charge. So now if we are denoting this electric potential as V, then V is equals to electric potential energy is always denoted by U, okay, and charge is denoted by Q. So V is equals to U by Q, or work done, if you will write, so work done upon Q. So potential is very near or very much related to the potential energy or work done. I have to remember this, and so the potential is equals to U by Q or W by Q. Electric potential difference between any 2 points in an electric field can be written as, suppose here this is the charge we are taking, this Q charge we are taking here, and near to the Q charge in the electric field of it, one charge we are taking, that is Q0. So there is a potential difference between these two charges, and that potential difference can be written as, here suppose this is the Q0 amount of charge we are taking, and here this is Q1 positive charge. There is a potential difference between them. Okay, electric field is there, and this is the electrostatic force of repulsion in this direction, and suppose this, the charge Q0 is at position A and this is at B. So this is the potential, V1 is the potential of this, V2 is the potential of this. So change in potential V2 minus V1, we can see that is equals to U2 minus U1, the change of energy, potential energy, divided by, or the work done to bring this charge from this position to this position. Whatever work done is there, that work is so here this work is done because F is the force, electrostatic force, and against the force we are moving this charge from this A position to B position. Then work is done, and this work done is converted into the energy, and that is known as the potential energy. So whatever work done, small work done to move this charge from this A to B, let us consider this small distance covered by this charge from this position to this is dr. So that small amount of work is done to displace the Q0 charge from A position to B position. So small work is done, so W we can say, and that is divided by Q amount of charge. Now let us consider here the potential energy, and the equation for the potential energy is potential energy of a two particle system at a distance r from each other. This equation we got in the previous lecture. That equation we are writing of this energy, and that is at distance r we are taking two charges, so the equation for the potential energy we are writing, that is U, and that is equals to 1 upon 4 pi epsilon 0 r, okay, into Q1 Q2 upon r. That is equals to, now here single charge we are taking. Here these are two charges. Suppose this is Q1 charge we are taking, and this is Q2 charge, and this is the distance between them. Both are two positive charges we are taking. Now if I want to take this Q1 here, so Q1 upon 4 pi epsilon 0 r I am considering together, and the remaining thing will be and this will be not there. So now this I am considering here. So total r I am considering inside, Q1 is also inside, then only Q2 will be there. So what is this thing? This is nothing but, this whole thing is nothing but the potential. So I'll write here the potential is equals to, due to this Q1 charge, so it will be now V1, okay. So V1 at r distance we are considering, and so I'll write r here, and Q2 is the second charge. So in this form also you can write the energy, potential energy. Now let us consider here Q2 inside. Then how will change this potential energy? That is equals to, let us consider this equation as, first of all, This is equation 1 we'll consider. And now the same equation here we are considering. It is inside I am taking Q2. So from this Q2 upon 4 pi epsilon 0 R. Okay, the remaining thing will be here only Q1. So from this we can write here UR is equals to, now this is the potential due to Q2 charge, so V2 will write, and that is at distance R we are mentioning here in the bracket, and so remaining will be Q1. So this is our equation 2. So in these two form we can write the potential energy of the system. So in this lecture we will stop here, and in the next lecture we will think about the comparison between the potential and the electric field. Thank you.